Welcome to Modern Development Technology and VFP. If this isn't the session you wanted to attend, you are at the wrong event.
A little louder.
I try. So this slide actually tells you how old I am, because younger people, they don't get or don't use credibility based on how many years you have been an MVP, how many articles you have been written, how many conferences you have spoken at. Instead, it's based on crafting sophisticated and thoughtful responses or posts on social media and being endorsed by the expert in the same field. So why am I talking in this session and not binge watching on Netflix today? So one of the things is change comes really slowly and steady. So every time there's something new happening in the world, it seems like we had this in VFP like 10 years before, and it's nothing new. And at some point, the power of compounding hits, and I go to Stack Overflow, and I can't answer a question. Not because I don't know the answer, but because I don't understand the question. So people say that if you try to explain something to others, that helps in your understanding. My wife didn't want to, so that's why I'm sitting here and trying to explain things to you, because there's really so much change in the past 20 years. So what's this session about? It's not about what I've written in my session proposer, because I figured out I can't speak that fast. So this session is a little bit different than my usual sessions where I deep dive into something, I hope. So you might already know much of what I'm talking about in the next 70 slides. So the topics I'm talking about today is first a general overview of how software development has changed since VFP 9 was released in 2004. And the focus topics are those that have been bothering me most in the past year, and which is Docker and asynchronous development. So those are the two core focuses I'm talking a little bit more today. So let's talk about 2004. VFP was still, we weren't the most popular group, but we were still a viable group that developed new applications in 2004. Microsoft was totally different, completely closed, everything secret, and focused on selling as much Windows Server and SQL Server licenses as they could. When we were talking at conferences, we were actually quite modern. We were talking about design patterns, about solid principles, about object orientations. We had a client-server architecture. We were using XML and SOAP. So we were kind of like everyone else. Everyone else didn't do anything different than we did, just used a different language. And at that time, applications were installed locally, because that's where Microsoft made money, selling Windows licenses and selling Office licenses and doing all these things. Can you imagine living in a world that has no YouTube, no Facebook, no WhatsApp, no Instagram, no Twitter, which some call X today, no Stack Overflow, no Google Maps, and no Netflix streaming? Sounds like a horrible world, but that's a world we lived in 20 years ago. And if we ask ourselves today, what is AI doing in 10 years? Well, let's look back in 2004 and imagine what we have thought this world would look like today. Hard to say, but definitely different than we imagined. VFP applications are kind of a little bit special. They are usually used to run an entire business. So it's not just a tiny part of the business. This application is running the business. Everything that needs to be done on a computer is done in a VFP application. They often originate from within the business. There was one person who was working there and was interested in computers, so they started doing something, created first applications in FoxPro, because that was easily accessible, unlike C or C++. At the same time, people were using computers in the office, but a lot of people didn't really have computers at home. They had a phone. They were using texting, so that was about the most modern communication people used. But many of them didn't really need a computer, because there were no social media that they needed to attend. Today, there's no new development that's being done in FoxPro. It's a thing of the past. In the new world, we have a new infrastructure. Our users have different expectations. Applications have completely different interfaces than what we have created, and the experience users have is completely different. So let's look at these changes. One of the changes we've seen in the past 20 years is that everything becomes temporary. Data is not expected to last forever. If you ever try to switch to a different cloud provider, or like we did, switch from Slack to Teams, trying to get all the data out of Slack, it's apparently an enterprise feature. Other cloud software don't even let you export any data. So data isn't permanent. Access to features isn't permanent. It depends on whether you have the right hardware at the right moment and whether you have paid your subscription fee. Same with ownership. You don't own anything anymore. You just subscribe to it. And you depend on others to be able to access it. If you are offline, you probably can't listen to a lot of music and stream unless you downloaded things beforehand. Also, we are virtualizing our life. And this is all done by software. That's why we are talking about this in a software conference. So what we see is that paper trails completely disappear. Nothing is printed on paper anymore. It's all PDF files, all records in databases. So even property or money or ownership is all digital. If you buy shares at Microsoft, you don't get a paper that says you bought the shares. You just have a number in your account that changes, and it's stored on a computer. And you have to trust the system that it doesn't get changed. Also, books, music, art is all becoming more digital. Most people stream on Spotify or Apple Music or any of the other services. If you want to take music offline, it's becoming hard. And also, we figure right now in using AI that even text, video, and audio isn't reliable. You can't trust a video anymore. I have a picture of you doing something. It's not worth anything anymore. Everyone could have made that picture. So we see a change in how software is affecting our lives. So we are writing software that defines people's life, and how people are using our software defines what we do next in software. It's a circle that goes back and forth. It used to be different. It used to be that software defined what the business is doing, and what the business was doing defined how software was working. It didn't affect people's life. It just affected businesses. And because we now live in a world where you can't own your computer. Like, if you have a computer you haven't turned on 10 years, you likely cannot turn it on again, because it has root certificates that are outdated. It can't talk on TLS 1.2 or 1.3. It can't connect to an update server. It can't do anything. Some of the software might be from vendors that are out of business a long time ago. So many things become temporary. Even signing documents is depending on how the certificate, how the cryptography is working, and all of that phases out over time. Everything that is securely encrypted today is not securely encrypted in 10 or 20 years. And that also leads to a situation where something like archive.org, the time back machine, is kind of the only barrier or the only last line of defense against rewriting history, because everything on every website can change. So you don't know what has been written 20 years ago in some newspaper, because you don't have a newspaper. You just have the online website. Users also changed. Now that users were using a lot of these things at home and for social media and other things, users switched from learning. It used to be that if you wrote out a new software, users were trained, and some of them even read the manual. Today, you don't have a manual. Users are just trying to do something, and if they stumble across something, they just want to fix it in some way. It's not that they need to be trained anymore. We also have low expectations in quality. How many times has the airline or the bank or the insurance company changed the app and you couldn't access what you could do, and a lot of features were suddenly gone? So people don't have the same expectations of what software should do than it used to be. We also see that because everyone is accessible, everyone can contact everyone in the room instantly, no matter where you are in the world. So we expect instant responses, and customers are, if they run into a problem because they haven't been trained, they use an in-app chat and expect kind of a response within a minute or something. And yeah, for me personally, the most complicated change is that everything went to video and audio instead of text and pictures. So YouTube is the #1 search engine for young people. Maybe TikTok in the future, or maybe it's already TikTok. And when people are telling you wanting to send you a message, they send you a WhatsApp voice message instead of a text message. So the other thing is we see a constant stream of feedback and surveys. Every time you interact with anything, you get, please fill out a survey, please respond, how did we do? And this isn't just data that's somewhere stored, it's also used to evaluate employees. So if you don't give 5 stars on any interaction with a person, that person has a problem. So people are getting used to being constantly evaluated. All this is possible because we moved to a cloud-based infrastructure. That's not typical for FoxBook. FoxBook is running on a computer. You don't have software that's installed on customer side anymore. It doesn't have to be in the cloud. It can be in your own data center if you have your own data center. But it also meant that we as software developers have more responsibilities, because before that we just had to provide good software and then the customer had to install it or paid us to install it. And then the customer's responsibility was to run it. Now it becomes our responsibility to run it and maintain it and fix things. So we are involved more than we were in the past now. Also, we have a different payment model. There's a difference between what the customer is paying, which is usually fee-based on number of users, number of invoices, or some other metrics, whereas our cost is being based on number of requests, amount of storage we use, minutes of computing that we require. So we have to actually actively monitor things, because otherwise our costs might spike suddenly because we don't realize that something is slow in our application and the amount of computing minutes goes up. So that's new challenges that we have had to face, and most of you face day to day in their own business. As I said, it's nothing new for you. Applications are also different now. It's not the one application that does everything in the business. We see a lot of smaller applications. One application is for banking, one application is for invoicing, one application is for payment. And even if it's bundled in one application, it's usually a number of different services, our own services and services from third parties that we are using. We are combining different services into an experience, and we build a more experience instead of just the one experience. And nothing we build today lasts forever, because if you run a web application that you wrote 10 years ago, you probably can't even compile it anymore, because all the tools are not available, the images are not available, the packages are gone. The change we've seen is a move to a service-oriented architecture. API today means a web API. It's not a Windows API. So our software is running on a server in the backend, and it's communicating with the client using REST or gRPC or GraphQL or SOAP or any of the other protocols that are available. With this, we had to deal with new things like queues. If you have multiple services that need to communicate, you have to send message into a queue and then process them. And we have new things that we need to take care of. It's like a circuit breaker. If one service is failing, you have to decide, can you keep sending messages to that service, or do you have to stop or do something else or reroute? So things like a circuit breaker just control the flow of messages, which we didn't have in the DOS FoxBook application. Everything is, there's just the load of one person. Today, what we usually see is microservices. Microservices are independent small services that can be deployed independently and can be scaled. So if you have more users, you just run more instances of a microservice in order to get more performance. These are often used with a REST API or any sort of web API. And one of the differences between a microservice and the application services that we might have written before is that they are domain-driven. So you have a customer service, you have an invoice service, you have a messaging service or something, but you don't have the application does-it-all service that is providing everything. The most common deployment method of microservices has become a container, not for FoxBook applications. That's because we don't use containers in FoxBook applications, but for most other applications, Java applications or C# applications that run offer web services, container has become the default deployment for most people. Container is part of a DevOps structure, which is another thing that changed. In the past, we were developers. We provided a software, and then even in big corporations, we provided either a setup program or we provided instructions how to install and get these things running, like what components you have to install, what ports you have to open in the firewall. But it wasn't our problem to run this software. It runs on our machines. That's good enough, and then someone else takes over. In the past, what changed is that the development and IT operations have been merged. So we have development and operations, DevOps, which means that the same team is writing the software and running the software. This is only possible through continuous integration and deployment. So everything you write is being deployed and monitored, and only possible if you automate everything. If you are trying to set up 100 servers manually, that's not going to work. And even especially if you have to add load balancers, firewalls, all kind of different infrastructure in between. So all of this is now being done in scripting or in config files, which has basically the name infrastructure as code, IAC. If you have complex infrastructure like several services, several databases, firewalls, load balancers, filters, you need to orchestrate them. You need to somehow manage all of these instances, otherwise it's getting too complicated. And tools that are common for this is like Kubernetes cluster. They provide a shared logging mechanism, so every of these microservices can send logs to the same instance, so you have all logs in one place. And they also provide a management surface, so you can see the status of each service, you can see what they are doing, and where they are failing. Kubernetes also takes care of load balancing and monitoring health checks. So if a container is failing, it can restart the container, or if it's gone down too many times, it notifies administrators. So yeah, basically Kubernetes is a way to run multiple things at once. Continuous integration and continuous delivery or deployment, it means that we are using a pipeline to push things straight from writing things to deploying things. We can't do this in a desktop application like FoxPro, because it would mean that every time we make a change in our program, a setup would run on the client computer, and they would constantly install a new setup. That doesn't work. So it's a mechanism that only works because we have moved to the web, to the cloud. Continuous integration is based on pipelines. A pipeline is a definition of what happens once you check code into your mostly Git repository. The change is detected by build servers like Jenkins or Argo CD. They build the code, they build executables, or they build the project, they build a web package. They run unit tests, integration tests, all kind of other tests. And what's important these days, they also scan for security issues and for code quality issues. Because as you know now, things that are secure today might completely be broken tomorrow because there's a new vulnerability that has been discovered, and that's has a 0-day impact and might be exploited instantly. So we always have to scan our software for security issues. Once things are built, usually into a container, this container is pushed to something like an EC2 instance or into the Azure cloud, and some provider using either pull deployment or push deployment. Everything that we do is configured in scripts. So that's where Docker comes into place. Because container is something that runs on the Docker engine. There are other container engines, but Docker is the most popular and basically the name for container. So what is Docker? Docker is something that it's a strange concept. It looks like it's a virtual machine, but it's totally not a virtual machine. It's something completely different. It's more like you can think of it as an application packaging mechanism. It's just a way to package your application. It's not a virtual machine itself, which means it has also certain limitations. For instance, a container can only run on the same CPU architecture than the host. You cannot run an ARM container on an Intel computer or vice versa. And because a container doesn't contain everything of the operating system, it doesn't contain the kernel. It just contains the user mode part of an operating system. Therefore, the kernel of your host has to be the same as the kernel of your container, or at least it has to be compatible. Docker originated in Linux, and it's basically just running a process, forking a new process, but it's using namespaces and isolation and network mapping to more or less isolate a process from the host. So it's running on the host, it's running as a visible process, but the process itself has a different view of the computer as the rest of the computer. Compare that to a virtual machine. On a virtual machine, you install an operating system, you install all applications you need. You have virtual hardware. So if you have a 64-core computer, you can install a 4-core virtual machine on that computer, and the virtual machine only sees 4 cores. In a container, it always sees the CPU. So a 64-core host means you have a 64-core in your container. You cannot clone a virtual machine easily. You cannot just run up multiple instances. You run into problems with network configuration, with the system IDs, so you have to kind of do something about that. And virtual machines are usually long-lived. It's something you need to maintain. You need to update them. You need to buy licenses for firewalls and other software. It's like another computer. Whereas a container is something that is being created and usually destroyed as soon as it isn't needed anymore. There's no maintenance on a container. In Docker, an image contains the operating system, and you use an image to generate the container you want. And if something changes, if the operating system changes and there's a new patch out there, you don't update that container. You just generate a new container using the newer image of the operating system, the new base image. It's really more like a setup. Think you created a setup, that's a container. It's not a virtual machine. That means what Docker is not, it's not something you create once and then it runs everywhere like a virtual machine. It's something you need to create specific for a host because it has to match in CPU architecture, it has to match in kernel version, it has to match in a number of things. It's also not a protection against changes in hardware. If suddenly something doesn't run on 32-bit, you cannot just use a container, a 32-bit container, and run it on a machine that doesn't support 32-bit, because it's really just running the software. It's also not a way to keep old software running because the software is still running on the same host, on the same operating system. You cannot run a DOS container if that existed on a Windows 11 64-bit machine. On Windows, Docker can be, there are Windows containers and there are Linux containers. You can use either one, but not both at the same time. So Docker basically says, I'm switching to Windows, I'm switching to Linux. And that's because containers on Windows usually run in a virtual machine. So they, on a Windows 11, Windows 10 client, they can't run on the system because there's no Windows 10 image or Windows 11 image. All the Windows images are Windows Server images. So Docker on Windows is creating a virtual machine that has either an Ubuntu image or a Windows Server image or Windows Core image where it runs. There is the possibility of running a Docker image native, a container natively, but in this case, the host has to match the container. So you cannot just run a Windows 2016 container image on a Windows Server 2022 server. And one thing that I came across when I was testing for my presentation and switching back between my regular user and my presentation user is that only one user can actually run a Docker instance at a time. It gives error messages for the other users if they try to start a Docker machine. Docker, because it's an isolation technique that on Windows requires a virtual machine, cannot necessarily work or doesn't necessarily work in a virtual machine. So on this Mac, I have a virtual machine, but I'm not using this to run Docker because I can't nest virtual machines on this machine. It's also using a different architecture. It's using an ARM processor instead of an x64 system. So you might have to have a physical Windows machine in order to run Docker on Windows, depending on how virtualization is supported. Skip that. Docker uses a layered file system. So basically, it's a set of commits. Every time you do something and you commit, you create a read-only layer of your file system. And everything you change then, it's on top of that writable on top of that layer. There's one writable layer on the top, and every other layer is read-only. So you get a Windows image from Microsoft, that's read-only. And everything you do on that image, that's the writable layer for you until you commit and say, okay, this is my new container, my new image. And then this becomes read-only, and our changes are again in the top layer. The advantage is that if we only have read-only layers, we can actually share them between containers. We can have multiple containers being based on Windows 2022 server, and all containers share the same exact file image because it's read-only, it doesn't change. All of them can use the same base image. You don't have to have multiple copies of Windows 2022 server when you run a Windows container, and you don't have to have multiple copies of Ubuntu if you run Linux containers. All containers share the same base image. So that's one way how Docker makes things more quick in execution. Docker containers are usually in registries. There's Docker Hub, the basically default repository for Docker. But Microsoft has a container registry as well called MCR, Microsoft.com, where all the Microsoft images are stored. They are not stored on Docker. Azure has a container registry that you can use to host your own containers. And of course, GitHub has a container registry too. When you use the Windows container, just because it's downloadable doesn't mean it's free. You still have to pay licenses. On Windows 10 and 11, you can run a Windows container only for development. You cannot have a production Docker container on a Windows 11 computer. It's not allowed by the license. Also, the number of licenses you need, I can't tell you because it depends. Microsoft requires a license for the host system, and then depending on the isolation mode, they might require another license of Windows Server for every single VM. And then you have the Windows image on top of that you're using in container. So it really depends on the contract, and you need to ask Microsoft. Same for matching versions. I try to figure out what version of Windows is running on what version, and it's kind of messy. The best approach is try it, and if it doesn't crash, it works. Docker containers or images are created with a Docker file that defines what base image you want to use, and then what other images or what other actions are needed. That's a way to basically, that's like a setup script. That's how you build the setup. It's like our inner script we use to build our setup file. It's not necessarily not required to have a Docker file, but most people use Docker files. You could actually commit manually. You could just use Docker and say, okay, I'm done with that, commit, and then you have another layer. So let's look at how you can use Docker in VFP. So finally we get to that point. One of the problems I had, at least as a FoxGet developer, was that customers were using SQL Server, and everyone was using a different version of SQL Server. And everyone was using a different configuration of SQL Server. So I had to have multiple instances of SQL Server. I had to have multiple web applications running in IIS on my machine. And it was all running all the time and taking up resources, unless I stopped the service and then figured out I needed to start the right service in order to keep working on that project. So Docker can help us with that, and I'll show you in a minute. We also, with a container, you have sort of a standard system. And if the other computer is similar to the computer that you have, same operating system, same CPU, you can use a container to move load to another computer with some restrictions. It's also a great way if you want to have a configured instance of SQL Server. Like most projects require some sort of SQL Server or Postgres, and it needs to be configured. There needs to be a database, and it's sometimes difficult if every developer is hitting the same SQL Server because you can't restart it, you cannot make changes outside of what you always have to think about how you impact others. So by having a Docker container that's defined, everyone in your team has the same configuration, uses the same SQL Server, and it basically means you get repeatable results. So let's look at SQL Server. SQL Server, SQL Server, SQL Server. And with a Docker container, you can install different versions of SQL Server. You can deal with if some users are using the SA user and using different passwords. So you have to have multiple servers. You have to have multiple servers. A Docker machine is also pretty quick in starting. So you can actually use a Docker container as a SQL Server in a test and get a clean state every time you start the machine. It takes a second or 2 seconds to run up a SQL Server Docker image. So it's really quick. And you can do tests repeatedly without having to resort to making a backup and restoring a backup. So let's look at what's involved in doing this. The first thing you need, is over here. You need to install Docker. It's a download, it's available, it's free within certain limitations. It's as everything, it's a subscription, and there's a free level, and then there's a paid level, and then there's a really high paid level. So once you install this, you can either do things interactively, like browsing through images on the hub, or you use the Docker command. So let's look at what. So in this case, we are pulling an image from the Microsoft container registry, which is Microsoft SQL Server 2022. And then we create an instance of that image, which turns it into a container. The image is the thing you run. And once you run an image, it becomes a container, and everything you change in the container does not change the image. Our container will named MS SQL 2022. We have to accept the EULA. We do this by just passing a variable, but that means you agree to the license of Microsoft. And that says that if you have to have a full license of Enterprise Server if you're running this on production. We pass an SA password, and we map the local port we are using to the port inside the virtual machine. So once you notice that we currently have no container running, or no container showing up at all, we create the container. So that's done. Now we have a container that has SQL Server, and it's already running. So that's how long it takes to run a SQL Server container. Once we have the SQL Server container running, we can, and hopefully everything works, access it. In any SQL Management Studio using ODBC connections, ODB connections, and this is Azure Data Studio, which I'm using. You notice that we don't have any databases because that's a blank image. So the first thing we want to do is get a database in there. You can, again, do this on the command line. I'm showing you the interactive way. Once you have a Linux image running, this is Microsoft SQL Server on Linux, on Ubuntu. You can go into the image, and then you can browse the file system. So this is the file system on the machine. You see that there's a modified node down here. This means everything else is unmodified, is in the base image, and here's something we did change in the container. So data is stored at var opt MSSQL data. And wait. And I have an image down here that I'm just dragging. Come on. Now I have to import. Documents. Come on. Nah. Import. Okay, let's try it again with drag and drop. Okay. Plan B, or Plan C actually, recreate the database manually. So let's create a database.phoenix. Let's create a table. Come on. Go away. Let's create query. And run this. Okay. Now, so yeah, now we have a database, we have values in there, and we can select star from sky, and we get comma connection. Answer. Big database. This one. Yeah. And we get data back. So now this is a SQL Server that we could use in Visual Fox Pro. Just like a native SQL Server, we have an image that if we stop this image, the computer, it would just stay at the state it was and then would continue once we run the image again. So that's one thing that if you copy files into the container, then let me show you. So this script is running the bash on the machine as a root user. The Microsoft SQL Server runs as the MS SQL user, which is different from the root server. If you go into the virtual machine and go into the terminal, let me show you. Exec. So that's bash, and I'm trying to get into SU. SU root. I need to enter a password. And that password has been created by Microsoft, and it's not a public password. You don't know what the root user's password is from within the machine, because that's something that somebody else has created. But if you go if you run the Docker exec command, you can specify the user. You don't have to know the password. So I specify user 0, which on a Linux system is the root user. And if I run this, I now have root access. And I can go to the data folder and then display everything inside there. And you notice that the user from everything I added is a different user. In this case, it's root. If you drag and drop, which didn't work for me today, it did work yesterday, I get a different user on my system. It was 501. The problem is if the user is not MS SQL, you cannot attach the file. So you have to change the owner of every file in that data folder. So what you do is you change the owner to MS SQL for all files. Change owner is the Unix command for changing the owner. And it doesn't work for root, but it does work for all others. So if you ever get an access denied message when you do anything in SQL Server Management Studio, that's because the file you're trying to access doesn't have the MS SQL owner. So there are a few gotchas on this. If you run Docker 4.34, which is the current version of Docker, you notice that you cannot install any other container except Microsoft SQL Server 2022. Because Docker changed the underlying Ubuntu kernel version between 4.32 and 4.34, and the old container images are do not run on the new kernel. So they just crash if you start them. And Microsoft is not providing updates for all images, just for some images. I ran into this. I was using the Azure version of SQL Server because it's a native ARM version, but it doesn't like it. Also, because you don't have a certificate or don't know the certificate of the SQL Server, you have to allow connections to bypass certificate checks for connections. And as we have just seen, you also have to change the owner sometimes. So let's look at something else you can do with SQL Server that is new since FoxGet came out, and that's called Jupyter Notebooks. Jupyter Notebooks is a technology that came originally from 3 languages: Julia, Python, and R. That's kind of how the name comes together, but it's actually named after Jupyter because of Galileo. But anyway, it's a technology that mixes text and code. So you have a notebook, you have text, you have code, and you can run the code within the notebook, and the results of that notebook are stored. It's usually meant for data analysts, or data scientists, so they can create artificial AI models and pass data in and then document what they have been doing. So it's actually a scientific tool. But Microsoft Azure Data Studio does allow us to create Jupyter Notebooks. So I've created one, and if everything works, I hopefully am able to open it. So let's see. So root, code, and meeting. Jupyter source file. So what I have here is a document that has text cells like this one, and it has code in here. So you have both in the same document. You can, in this case, it's a virtual meeting. It's an imagined meeting that I documented. So John explained us that we should think bigger, ask for ideas, and we want to add the sun to the sky in Phoenix. So everyone agreed on that. So we can now run this. I have to select a connection, change connection. And because you can't specify the database, you also have to specify the database in the connection. So let's first pick this one and then change it to Phoenix. So we have created a table that had we have to create. We had to have a table that has only one column, moon. So we want to add the sun. So now you see that the command completed successfully. You have the execution time. And obviously, you needed some value. We couldn't agree on some, so we just say sunrise. And we also have to check that this works. So we do a select star from sky again. And we have a full moon and the sun rises. And when you save this file, it actually saves the results with the file. So if I close this and reopen it again, you see that whatever we did is still in there. The file itself is just a JSON file. It has items in there with a cell type called Markdown, which uses Markdown as text. All the text you've seen was Markdown. And it has cell types code that contain the code that's been executed. And it also has the outputs. That's the original one. And that's the one we created. So it has the results in there as well. So how can you use that? So one of them is to document decisions. So you have a decision. You decided you need to add another table in some meeting or for some ticket or whatever. So you can use a document and describe what you did and why you're doing this, and then put the code in there. You can also describe specifications. I often have to have a specification of some file format, some service, and I needed to store the results of that service inside the SQL Server database. So I put the documentation for that service for every column that I add, and then add the column in my SQL Server database, so I know where the data is coming from and what possible values are valid. And you also can use it to research. If you have a database and the customer has a problem and you just can't figure out why, you can document your way of thinking. What did you do to try? What have you tried? See the results and see that it worked or didn't work. So it's a way to kind of leave a trail of what you did in SQL Server. The other thing you can do is Azure Studio has the ability to export. Let's move over here. There's the export. To export this notebook to SQL. And if you export it to SQL, what you get is a SQL Server file. So if you have documented your changes, you can export it to SQL. And this SQL file, you can just send in a Visual FoxGet application to SQL Server to update your SQL Server database. The only thing you have to be aware of, if you're using images and you paste an image, it's not using a link, it's using a data URL and base 64 encoded image. So this can be very long. And ODBC has a limit of 128K for the query string. So for images, you might want to remove those images from the file. But otherwise, you can just take this output and send it to SQL Server within your application. So, yeah, two more things. When you use a Windows container, you can use a Windows container for Visual FoxGet, for instance, to maintain to run the build process and the testing process. So instead of building it on your machine or having a dedicated build server, you create a container images that installs all the tools you need, like Visual FoxGet. The best is if you have a repository that has all the tools, then you can just add the entire repository to the Docker container. The advantage is if you have a team, usually everyone has configured FoxGet a little bit different. Paths are different. Sometimes the tools have a different version. You are not using the same version of Gen menu or something. So the output between different developer computers is usually slightly different. Having a Docker container allows you to just run the same things over and over again. In order to run Visual FoxGet in a container, one thing would be of great advantage if Fox would behave more like a console application. So let's try and do that. So a console application in Windows, the difference between a regular application, a Windows application, and console application is in the optional image header in the PE header of the XE, it's the subsystem component. A 2 in there means it's a Windows application. A 3 means it's a console application. So we find the 2 in the VFP exe at that point. So what I've done is I've created this make VFP9 console program, which is just changing the 2 into the 3. And when I run this, I get the VFP console. Actually, I can run this. No, I don't have to. VFP console exe. So let's check out what this does. I have a simple program which is just using my console class, another helper class that I've written, uses console write line starting a message box, another write line, and then it terminates passing the exit code 1 back. So something was wrong, otherwise it would be 0. If I run this program using VFP9 exe, you see the console down here, it's not waiting. It's just running the Foxbar application and returns. However, if I do the same thing with the VFP9 console exe, which is the same exe as VFP9 except for the 1 byte, you get suddenly the output of the console, and it's actually waiting. And only when I finish this, you see the other line and you see the output. So you still get a window. So if you want to avoid the window, you have to do a little bit more things. So in this case, I have what you usually would do. You have a build program. And in order to see something, we are just waiting for 2 seconds here. So in order to run this without the window, you have to provide a config FPW where its screen equals off. You also have to specify the program you want to run as _startup, because the window appears as soon as Fox was ready to do anything, which is after the _startup executed. And when you call the VFP console, you have to pass the /t parameter to prevent the screen, the Foxborough screen, to show up. If I do this, you can see that it's starting the build. There's no Foxborough window coming up, and then it's after 2 seconds, it's terminating, and it's just done. And this is, of course, output that you can redirect, or any build server will capture that output and use it for anything you need. So, and you need VFP9 exe to build the exe. You cannot do it in an exe you created, because build exe is one of those commands that are only available within VFP itself. You can turn your own applications into console applications as well. The position might be a different one. You can do one of 2 things. You can pass the entire header, or you can do just do what I did, just do change 1, 2 to a 3 at a time and see when the behavior changes. And then you got the correct position. So, any question on that so far? No questions? No questions? Okay. Let's talk about a completely different topic, closures and asynchronous development. Suppose you want to sort a list. Either way, either alphabetically on the left side, or kind of smart sorting, where you sort it alphabetically, but the numbers are sorted in numbers. So 90 is smaller than 100, and not larger because 9 is larger than 1. So what you have is you have a sorting algorithm, which could be quicksort, bubble sort, pancake sorting, whatever you want. And you must compare 2 values, which can be equal, less than, or larger, greater than. And you need to combine those. So if you want to switch between quicksort and bubble sort, using smart sorting and alphabetic sorting, what you can do in FoxPro is you create a quicksort class and then you subclass it either in alphabetical and smart, just overriding the compare method inside. So you end up with 6 classes. You alternatively could create a quicksort class and a bubble sort class and then have an object that is a comparer. So you assign the OComparer property in the quicksort and a sorting class, and then have an alphabetic or smart comparer class. That's how we would do it. We would still have 4 classes, and it's not exactly obvious how these things work because the different classes are located in different places. They are not in the place where it's used. You have the alphabetic comparer class, and what it does, to figure out what it does, you actually have to look at the code, which is somewhere else than where you instantiate the quicksort class. So let's talk about first-class functions. A first-class function is a function you can assign to a variable and then use it as a variable, call the function, or pass it as a parameter to something else. So that's down there, that's JavaScript. You assign a function to compare, and the content of the compare variable is the function. It's not a pointer, the content is the function. It's of type function. So you can now, and we are switching to C# right now, create a quicksort class and then just have a function that receives 2 strings and returns an integer as a parameter. And then use that, whatever that thing is that has been passed in, to actually do this. So we would create a new compare function using a lambda expression in this case, which takes value 1 and value 2 and compares it using invariant culture ignore case. And then we pass that method into the quicksort object. So that's how you can kind of customize things if you have a function data type. What this is actually an anonymous whatever function, which is a function that is defined in another function. It doesn't have to have a name because it can directly be assigned to a variable, and we express it either as a function or as a lambda expression tree. So what's a closure? A closure is when we have a private function that has access to the outermost function. Let's look at this. It's easier to see in code, I think. Let's look at this in JavaScript. So we have a function here, which is called create incrementer over here, which receives one value called start value. It's a parameter called start value. Then we store this value in a local variable scope to the create incrementer function. And here we are creating a new function, and that new function has access to the current value variable, and it has access to the start value variable. Then the function returns. And now what happened in FoxPro is, because those variables are local, both of them, they would disappear. They would not be available anymore. But because we created a closures, because we created a function here that is inside another function, this function retains the scope or the environment of the function it was created in. So in this case, we create a new incrementer that has start value of 5, another one is at 9, and then we just call the start 5 function, which would increment the value. So it will increment the one that is on 5, and then we do the same thing with 9 to show that those values are actually independent. So if we run this, you see that the return value of the inner function is 6, 7, 8, and then because we use the 9, the start value 9, it's now 10, 11, and then we switch back. So we have multiple copies of the variables that are inside the function that are retained because we assigned it to another function variable. That's a closure. A private function that has captured the environment of the function it was created in and has access to that local variables. Make sense? Makes sense. Closures can be difficult, especially in JavaScript. So let's look at this one. Here we have, again, an incrementer, and then instead of returning just one function, we return an array of 10 functions. So we have a result that's an array, and then we just do a loop 10 times. And every time we do it, we create a new function, same function we did create before, and push it onto the array. So we append it to the array, and then we return the array. And for each item in the array, we execute this function. If we do this, what you can see is that the values are all the same. Why is that? It's because creating a closure does not copy the values in JavaScript. It copies the variable reference, basically. You get access to that variable. And that variable is var scoped, as we have learned, I think in Scott's session. This means it's scoped to the function. And because it's scoped to the function, at the end of the function, it has the value 15. And that value is being accessed by every one of those closures. If we want to have a different copy, just a moment, a different copy for every of those variables, we change this to block scope, use let, and if we execute this now, you see that the values are retained. So in loops, you have to be careful that you actually create a new variable for every iteration. Yes?
I noticed it executed 6 times. That's because you said 5 somewhere. It starts at 0. Is that why it had 6? More than 6.
Yeah, it might be an off by 1 error. The question is why I said it was 5 and there's more than 5. I might just have an off by 1 error.
Thank you.
So let's go into asynchronous programming, the headache-making way of software development. The most important part, asynchronous development is not about multi-threading. It's about increasing throughput, about maximizing resource usage in a process. So it's really relevant for server applications, which is why we don't have it in a FoxGet desktop application. Let's assume we had it. Let's say we have scan async and scan. So scan, the scan function as we know and love it, reads a record and waits until the record is available and then executes the loop, and then it reads the next record. So suppose scan async searches the next record while we are executing the one in the loop. So scan for something, async, and scan. So what kind of problems would we expect? Quite a few, because suddenly it's searching for the next record, but that involves having multiple disk access to server, waiting for responses, and the server might decide to deliver responses in a different order than we asked them. So we might get the second record or the third record before the first record, because that's just happened to be the record that that server delivered quicker than the other. Also, if we do something like we check if this is duplicate record, and then we just skip it from a total or something. So you say if this value, group value, is the same one as the last record, then skip one or loop. That's not working because the order in which we are processing records suddenly is random. Also, if you want to maintain state, it's hard to do if the order becomes random. You also don't know necessarily what value. If you add something, you don't know exactly what value will end up because, again, all these operations happen in different order. And now suppose you have another scan loop that's asynchronous inside the asynchronous loop. What should happen? Should the outermost loop finish always before the, or should one loop almost finish? Or is that inner loop maybe another async mechanism that can process records at a different time? So you might actually end up on 1,000 record table. You might actually end up processing like 1,000 times 1,000 records at once. And you can't append. You cannot add another record because maybe the scan is already finished by the time your append is executed. Because even though you are in the middle, it might be the last record that scan would like to. It's not searching for any new records. So you can see that asynchronous programming can cause a lot of problems. It seems easy, but it's really different. But it's, yeah, complicated. So let's quickly, not so quickly now, we skip a few things. Yeah, let's start with promises. A promise is the eventual result of an asynchronous operation. Sounds good. So a promise is basically something that has a state. It can be pending. That means there's nothing yet there, or it can be fulfilled or rejected. So fulfilled means that the result is there. Rejected means the result isn't there because something happened. A promise has two methods. They have a then method and a catch method that also return a promise. So you can have one promise, and then you call the then method, pass another closure into the then method, another function, which is executed after the result of the first promise is available. And then you chain all these things. In C#, yeah, let's skip that one. Let's go to threading task. A task is the C# version of a promise. It stores the result inside the task, and it supports continuation. And the one thing that is different from the previous ones that we had in C# is that you can decide what to do after you started the task, because the result is stored in the task. And even if you haven't yet specified what should happen with the result, the moment you call the continue with method, you are either waiting for the results, or you use the results that already is available. A task is not a thread. Tasks are pieces of work that are organized, that are run at random order, really random order. If you don't have a task view in your debugger, that's totally confusing. And they run on a different type of thread, different threads, depending on how you call them and in what kind of application you're using them. Async in C# is not a feature in the language itself, or in .NET itself. Async is a compiler keyword that rewrites your method into a state machine. So it's basically a huge switch statement. I'm state 1, state 2, state 3, state 4. And every await is causing another switch statement, or another case statement, as we would say in FoxGet. And then it's running until it's always running the one state it's currently in. And then it's waiting for the next promise to get any result. And that's continuing then. So it's really a compiler feature that's based on task objects, but it's not a language feature. The problems of asynchronous development is if you try to mix things, if you try to do synchronous development and asynchronous development at once, this doesn't work. It doesn't work because a task requires that you have a topmost loop, and the task scheduler can say what task to execute next. He can't stand my talking about C#. So, but if you use something that is synchronous development, like getting the result property or using task wait, you might be blocking the task that is the thread that is executing task. So as long as you wait for the result of a task, no other task can execute on that thread. It's not happening. It's not usually a problem immediately because .NET uses a thread pool that has 10 threads. But as soon as you wait 10 times, you're blocking all threads. You're waiting for the task to complete, but are using the threads that .NET wanted to use to complete the task. So you get a deadlock, and the application hangs. So asynchronous development is not the same as multi-threaded development, and you are not blocking. You're never blocking or waiting in an asynchronous in a task. You just don't do that. It's always causing a problem. In JavaScript, things are a little bit different. JavaScript is single-threaded, just like FoxGet. So if we ever had asynchronous development in FoxGet, we would probably follow the JavaScript model. JavaScript has 3 steps it always performs. It has a macro task queue, which is whatever it has to execute, like a script tag, an event, a callback. And everything that's one of these things gets added to the macro task queue. And JavaScript is only running one at a time. So whatever is the first item in that queue, it's running that. It then has a micro task queue where all these things like then, catch, and await are handled. Once it finished executing one item in the macro task queue, it executes all items in the micro task queue until the micro task queue is empty. And then the next step is rendering. only after all these steps are finished, the DOM is actually displayed. So if you have something that's happening inside the JavaScript application, like an alert, even if you made things invisible before the alert, in the browser it's still visible because the rendering only happens after the script has finished. So let's look at what this looks like in JavaScript. So we have an asynchronous function that we define here. That's a function. It's doing something when it's being called. It's not called. It's just a definition right now. The first thing we do is we log start, and I'm probably running this so we can see that as it's parallel. So we do start. Then we set a timeout, and we set it to instantly trigger. There's no time. It's instant. But because the timeout is an event, it doesn't execute this code at this moment. It adds it to the macro task queue. It's added to the macro task queue and waits until the macro task queue is executed. That's why we see step 2 next. Start step 2. Then we queue a micro task. And because we are currently executing the macro task, and the macro task queue is executed afterwards, we are not doing any of this right now. And then we hit an await. We log awaiting, and we hit await. And this is adding another, is creating a promise. And once the promise is fulfilled, it's adding another result in the microtask queue. The script is now done. We have another microtask queue here, but this code isn't executed because everything after the await is being put in the promise. Once JavaScript hits an await, it's not doing anything else. The method is just finished. So next, its next step is after we executed the macro queue is executing the micro queue. So now we had this micro task queue queued up here. So that's the next thing that's happening. And then nothing happens because the promise is not fulfilled until this returns. And this is adding another item to the macro queue. So we are now doing the timeout in, no, this one, set timeout. We are now doing the timeout in the macro queue. And then nothing happens. And then our asynchronous method, there, which is fetching some data from an API, which takes some time. Then this triggers, again, this triggers in the micro queue. The micro queue is executed, and then we are done.
You have 3 minutes.
No, yeah. Oh, and then actually the remaining code is executed. So we queue another micro task, which is not executed. The stop is executed, and then the micro task queue is executed again. So it's kind of difficult, but that would be the way that we would see in Visual FoxGet, basically.
You have 2 minutes left.
Yeah, 2 minutes. 2 minutes. I know. We skip package managers. Just one thing. If this is what happened on my presentation machine when I was trying to show you FoxGet, I called FoxGet and it got error 35. It's already a bug. It's reported. Doug is working on it. If you ever get this in when you run FoxGet, you have to create a curl RC file in your home folder. This is my presentation user, and set the content to SSL revoke best effort, and then the error doesn't happen. Oh, generative AI, Gen AI. 1 minute left, I know. If you have issues with sending data to ChatGPT because you want to send private data, what I use is Yen AI, just the name is the long name for that. And it lets you run like Llama or other chat engines on your own computer. So I use Llama, 8 billion parameters. And this is now running locally on this machine. Actually, it's running on my Windows machine in my basement, and we are remoting into it, but it's running on the machine. It's not, yes, South by Southwest trucks. But it's doing these things offline. And the funny thing, or interesting thing is if you look at the model size, this is a 4.58 gigabyte model, and it knows about some conferences. It knows about Arizona. So everything it produces is encoded in this 4.5 gigabyte of data, which is less than some of Microsoft's patches they're sending out. Okay, so as I said, it's a lot to cover. Cloud applications is not the same as moving a Foxpo application to the web. It's using a completely different architecture. Docker is something you can use as a Foxpo developer. Asynchronous programming is something you quickly learn now and can employ it flawlessly.
Sure.
And if you haven't get FoxGet, then get FoxGet. So thank you very much. And yeah. So